All right, so in 7-4, we learned two special right triangles, 45, 45, 90, and 30, 60, 90. Okay, I broke this down like in a question. So this one says, find A if B is 10 root 2. So if I'm using the triangle that's on the left, this is 10 root 2. What do I know about this triangle? It's a 45, 45, 90 triangle, right? It's isosceles and it's a right triangle, which means it has to be 45, 45, 90. So the side relationships on a 45, 45, 90 are what? What's opposite the 90? A root 2. And then opposite the 45s would be A and A. So sometimes the variable they give you is the A. Don't let that confuse you, okay? So in this case, it worked out that if I solve this, if I say A root 2 equals 10 root 2, so to get A by itself, I would divide by root 2. And they cancel, and I get A is 10. And then these sides are both 10. So this one, A should have been 10. How many of you got it right? Okay, good. Questions on it? Okay, this one says find B if A is 19. So this time they're giving you the side lengths that were your A's. This would be A root 2, so this would be 19 root 2. All I gotta do is plug it in. No arithmetic involved there. Raise your hand if you got that one right. Okay, good. This says find D and E if C is 4. So now we're using the triangle at the right, which is what kind of triangle? 30, 60, 90. So in a 30, 60, 90, opposite the 30 is what? A, opposite the 60? A square root 3, good. Opposite the 90? 2A. So if they give you that C is 4, they're actually giving you the A. Then this would be 4 root 3, so D is 4 root 3. And E would be 2 times 4. Which is 8E. Raise your hand if you got that one right. Good. Questions on it? Okay, and then C and D if E is 50 root 30. Okay, so I'm going to mark them again. So this would have been A, this is A root 3, and this is 2A. So if that is the side that they give you, which is 50 root 3, then to solve for A, I do what? How do I get? Good, divide both sides by 2. So A is 25 root 3, which gives me that side C. That one's already given. To find D, I have to say A root 3, or 25 root 3 times root 3. And what is square root 3 times square root 3? Just 3. So D is 75. Questions on that one? Still good? Okay. So this last one, which wasn't on the assignment yesterday, right? I cut it off, right? Yeah. Okay, so we're going to do this one together. So this just has a combination. So don't let it scare you. It's just, this is a trapezoid, but it basically just has two triangles on either side. On the left-hand triangle, there's a 45, 45, 90 triangle. And on the right-hand side, there's a 30, 60, 90. So if I were to just grab that 45, 45, 90 triangle, then I know this is A, and this is A, and this is A root 2. This time I've got to solve for A. So A root 2 equals 6. Divide both sides by root 2. And then I've got to rationalize it. So 6 root 2 over 2, which becomes 3 root 2. And that's going to be this side and this side. So x equals 3 root 2. The 30, 60, 90, this is your A. This is your A root 3, and this is your 2A. But I need the other side. Yep.
Where is this? Is this still warm-up?
This is on the warm-up, but it's not on the warm-up from yesterday. Like, it's on the actual warm-up. I cut it off for yesterday. I didn't want you to freak out because I wanted to work through it with you. Okay? So if you look at this shape that's at the top, if I cut this off, what kind of shape is this? A rectangle, what's true about the opposite sides in a rectangle? They're parallel and? They're the same. So if this is 3 root 2 over here, then this one's going to be 3 root 2 over here. So my A is 3 root 2, and then I would take 3 root 2 and multiply it times root 3. And the rule with square roots is you multiply, if they're both under the root, then you multiply them together. So this would just be root 6. That's going to be y. And then z is 2 times a, and we just said a was 2 root 3. So 2 times 3 root 2 is 6 root 2. So a little application, because you have to have the knowledge about the trapezoid, about the rectangle, all that stuff, which is actually, like, we're going to get a lot into detail on all those shapes, all the quadrilaterals next chapter, so you have that to look forward to. Okay. But for right now, I would say you need to know how to do those individually, like the split of them. And then the diagonals for the square, and the altitude for a triangle, an equilateral triangle. So if I tell you that a square has a diagonal, what triangles am I making? 45, 45, 90. And if I've got an equilateral triangle with an altitude, what triangles am I making? 30, 60, 90. Okay, good. Right, so like I said the other day, I'm going to kind of blend 6, 7, 5, and 7, 6 together. In my opinion, they make sense when they're blended together. So we're going to focus between the two sections on 3 what are called trig functions. So we're getting into trigonometry. Trigonometry is the study of triangles. So specifically, we're going to get into right triangles. So a trig ratio is a ratio of the lengths of 2 sides in a right triangle. And we're going to focus on 3 trig ratios, sine, cosine, and tangent. And you're going to use these to find the measure of a side or an acute angle in a right triangle. So I could give you a triangle that's not necessarily one of your special right triangles, and one side, one angle, and you should be able to find everything else. So important takeaways from this is that every single triangle that we're going to be focusing on is a right triangle, okay? Or there's going to be a way to make it a right triangle. And then you're either going to be given one angle and one side, and you're going to be finding the other ones. You could be eventually given 2 sides, and you'll be looking for the angle, that kind of thing. But you have, as long as it's a right triangle, all you need is 2 pieces of information, and you can fill in all the rest. So the first one is the tangent ratio. The tangent, if you've got a right triangle, in this case, this is saying let a triangle ABC be a right triangle with acute angle A. The tangent of angle A is the leg opposite the angle over the leg adjacent to the angle. So tangent is opposite over adjacent. So if I'm looking for, yep.
Does it matter which adjacent?
Yes. So if you're looking at angle A, right? So say I'm using angle A. Opposite's easy, right? Opposite's the one directly across from it. It's the one it doesn't touch. Everybody sees that, right? But adjacent, technically, there's 2 sides that are adjacent to angle A, right? Side B and side C are both adjacent to angle A. What's true about side C?
It's right.
It's side C.
Oh.
It's the hypotenuse. It's opposite the right angle. So the hypotenuse always has a special name. The hypotenuse can never be the adjacent side. So when I'm looking at this triangle, opposite is A, but adjacent is B.
Wait, I thought you said not on the hypotenuse.
The hypotenuse can never be an adjacent side. So you're going to see when we get to sine and cosine that they both use the hypotenuse, whereas tangent uses opposite and adjacent. So if I asked you to find the tangent of B, what side is opposite angle B? B. And what side is adjacent to angle B? A. And again, don't ever use the hypotenuse. The hypotenuse is a hypotenuse, and it will come up in sine and cosine, but not in tangent. So this one just says, express tangent of R as a ratio, so it's going to be the fraction, and then tangent S. So the tangent of R is the side opposite R, which is what? 3, over the side adjacent to R, which is 8. Now do the same for S. What's opposite S? 8. What's adjacent to S? 3. So we're going to baby step our way into solving these triangles. Okay, now we're going to use the calculator. So a couple important things to learn about calculators. One, you each have there's probably like 10 different kinds of calculators in here. So our job is to figure out how to use each individual one so you're comfortable with it. You want to, bring the same calculator to class with you every single day because you're going to get accustomed to what this calculator does as opposed to that calculator, as opposed to that calculator, as opposed to the one you borrow from your friend 5 minutes before you're going to take your test and you don't know how to use it. Okay? Which falls B. I will not take time out of a test day to teach you how to use your calculator. So make sure you know before the test day how to use your calculator. Okay? So if you have a graphing calculator, if you're looking at like a TI-84, something like this, then you want to, who am I talking to? Okay, you want to look for your mode button. So your mode button is to the right of your, it should be a second button that's colorful. You want to find your mode button. And you want to make sure that the third line down where it says radian degree, fourth line down, that degree is highlighted. Do you see that? Okay, so the first two examples here are asking you to find the tangent of the angle. So depending on your calculator again, right now I want everybody to hit the little button that says TAN. Hit the little button that says TAN. If the letters TAN appear on your screen, then I'm talking to you first. Okay? If they're not there, then I'll talk to you in a minute. Okay? So if when you hit TAN, the letters are there, then you will first hit the trig function, which in this case is tangent. Then you'll type in the angle, which is 45, and then you'll hit enter, or equals. You should get 1. Okay. If you are the other people, the people that when you hit tan it does not appear first, then you will first type in the angle, so you will hit 45, and then you will hit tangent. So the calculator on the iPad is like that, okay? You will hit 45 first, and then you'll hit tangent. So now do tangent of 36, whichever way you need to do it. You should get 0.7265. So we're going to round this to 4 decimal places. 7265. Okay, so now the second part of this is saying the tangent of what angle is 2.475. So in these cases, you're looking for the angle and you're already given the tangent. When you're looking for the angle, you're going to hit the little buttons that are above the tangent buttons. So in this case, I'm going to put tangent -1 of 2.4751. So I'm giving you the tangent, and I want you to give me the angle. So above that tangent button should be tan -1. You'll have to hit shift or second and tan -1.
So you enter 2.
So same thing. If when you hit that, the tangent appears, then you do that first, and then hit the 2.4751. If when you hit tangent, it does not appear, then you're going to do 2.4751, second tangent. 68.0001057. Yeah, you're going to round it. Usually, it'll say like round to the nearest tenth, probably, for an angle, but this is 68.0. All right, now do the next one. So the second tangent of 0.8098, and it's 39.0005, whatever. So this is 39 degrees. Again, you'll usually round to 1 decimal place. This 1 decimal place is a 0, so I don't need to keep it.
You have to click second first, though.
Okay, so we're going to start this. It says now use this triangle. Again, we're baby stepping our way into solving these triangles. So the first thing it says, find the tangent of A. So use the side length to write a ratio of the tangent of A.
Can I look at his calculator?
Sure. So what's the tangent of A?
2/7.
2/7. Okay, now do the same thing for B. What's the tangent of B?
7/2.
7/2. Now it says find the measure of angle A. So if the tangent of A is 2 over 7. I gave you the tangent, you're giving me the angle. How do I do it?
We're finding the second.
The negative 1. So I do tangent
We're not on the same page.
negative 1 of 2 divided by 7. So this time you're given the side length. Yep, because a ratio is the same thing as divided by.
1 point.
How do you put?
15.945, which is going to be 15.9
Yeah. How do you put a fraction on a calculator?
divided by. So now I'm going to do second tangent of 7 divided by 2. What do you get? 74.05, so 74.1. We're going to round it.
You have to hold the 2 down, the second button?
You don't
No.
hold it down. You don't hold anything down. You just press
So what should make sense? What should happen when I add up angle A and angle B in a
They
right
should equal
triangle?
90.
They should equal 90 degrees. So is this a good way to check? That's 15.9 plus 74.1 equals 90 degrees.
Ooh, that's clutch.
Yes. Okay.
I see.
All right. So this says complete the triangle. Complete the triangle means find all the missing sides and all the missing angles.
Okay, well, C is 90 degrees.
C is 90 degrees. There's one. Okay? We know the side opposite A. We know the side opposite C. What's the next thing we're missing?
Angle CA.
We're missing angle A, angle B, and side AC, right? What's true about this triangle?
It's a right.
It's a right triangle. How do I find the missing side of a right triangle if I'm given 2 sides? Pythagorean theorem. What about those triples that you know? Is there one involving? Aha! See how the payoff comes. 8, 15, 17 is a triple. Now, how could I find one of these angles? Think about what we just did.
Do the opposite.
90, 30.
I'm so lost.
So you put A over, yeah.
So let's find the tangent of A, right? Let's start there. So if the tangent of A would be what? 8 over 15. So then to find the measure of angle A,
It's opposite, correct? That's what's going on.
Yeah.
yep. Anytime I'm finding the angle, I'm going to do the inverse tangent or the tan negative 1.
Okay, and then hold up. So tan A.
28.
You're using tan A to find tan negative 1.
I'm using tangent of A to find angle A, and when I'm finding the angle, I use negative 1.
So you use these things. You're just finding angle measures.
I'm finding everything that I'm missing, so the first thing I was missing was the third side. And then I have to
But
find the
essentially, we're
angles.
just finding the angles.
Exactly.
But then whoever named it tan is just confusing.
No, because the tangent is the tool you're using to find the angle, because you're going to eventually learn.
But how do you know that word tangent?
Oh, okay, I'm sorry.
Why is it like
We
that?
can't.
Really?
Yeah,
So what do I do right now? I just watch?
yep.
Well, you can use the calculator right now.
All right, so now how do I find B?
Yeah, they took it off.
And I'll give you a hint, there's 2 ways. I can subtract, all I have to do is, I know all of them have to add up to 180. I know the 2 acute ones have to add up to 90. So I can find angle B by just doing 90 minus 28.1. Yep. 61.9 degrees. Now what's another way to do it, and probably your best bet to do both if you've got extra time?
Tangent A.
Good. Tangent of B would equal what?
15 over something.
15 over 8. So then the tangent, negative 1.
Not 15 over.
Opposite over
Never
adjacent.
use the hypotenuse.
Oh yeah. All right. This is.
The negative one's going to remind you that you're not hitting tangent on your calculator. So when you're solving, you want to make sure you know the difference between them. Should you hit one wrong button on your calculator and get A wrong, now you're getting B wrong, and without the work to back it, there's no partial credit.
Would you say this is the hardest chapter?
Okay, this time I'm given one of the acute angles and one side. So I can't use Pythagorean theorem because I don't have 2 sides, I only have one. It's not a special right triangle like 30, 60, 90 or 45, 45, 90. These won't be because you can't use it that way. So the other thing I can do is first easily find the other acute angle, right? What would be my missing angle? 66 degrees. So now I know my acute angle. Okay, so thinking along the lines of tangent, because I can still use that same process, right? What is the ratio of the tangent of 24? What's the ratio? What's tangent of 24? X over 20. So if the tangent of 24 equals x over 20, how would I solve that for x? So if I just said what's the tangent of 24? Now I'm asking for a ratio. The ratio would be the side opposite, which is x, over the side adjacent, which is 20. So now, how do I get that equation solved for x?
X over 20 over 20.
If I'm dividing by 20, how do I get rid of it? Multiply by 20. So I'm going to multiply both sides by 20. And on the right-hand side, they're going to cancel, and I get x equals 20 times the tangent of 24. And then you can type that whole thing in your calculator. So if you are one of the ones that when you hit tangent, it doesn't appear, then you're going to want to work right to left. 24 tangent times 20. If it appears, then you can literally write 20 tan 24. You should get 8.9. So if you, then you're going to hit 24 tangent times 20. Oh, listen. Now you're going to learn two more ratios. Everything that we just did stays the same. The process stays the same. The difference is so we're going to get three total ratios: tangent, sine, and cosine. The difference is what combinations of sides you use. So tangent always uses opposite and adjacent.
Did you add some?
I'm gonna give you. Okay, so sine. Let's go to sine next. So sine is the ratio of the opposite side to the hypotenuse. Remember I said at some point we're going to bring in that hypotenuse. So this is when. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So three trig functions, okay, three ratios. So if I look at A here, if I'm trying to find the sine of A, oh my word. The sine is the ratio of the side opposite the angle over the hypotenuse.
It's confusing.
I'm so sorry. You're getting a whole lot of yelling today. So what is opposite angle A? A. What is the hypotenuse of this triangle?
Yes. C. What's good with y'all? Whoever said B, y'all need a moment.
Now we're going to use the hypotenuse because we're not using adjacent, we're using hypotenuse, okay? So the cosine of A is the side adjacent to angle A, which would be?
A. What you said? The side?
The side adjacent to angle A.
B.
Now B or C, but what's wrong with C? C is the hypotenuse, so C can only be the hypotenuse, which means it's B over the hypotenuse, which is C, okay? So all you have to do is remember, which is SOHCAHTOA.
What?
Listen to me. This is a word that you can ask like a 30-year-old adult, and they will remember the word SOHCAHTOA. And yet your book does not have it. It's the most valuable word you need to learn when you're using trig, because it's an acronym. So SOH means sine equals opposite over hypotenuse.
You tell us that for everything. Like, this is the most valuable word, this is the most valuable.
Okay, this is the most valuable acronym that you can use. So opposite over hypotenuse. Cosine is CAH. What do we think the A stands for?
Addition.
Oh boy.
Adjacent.
Adjacent.
Yeah, I'm gonna have to watch this.
Oh, hypotenuse.
Hypotenuse. Okay, and tangent is the TOA. What do we think the O stands for? Opposite. And the A adjacent. So all you have to know is how to spell this 9-letter word. SOHCAHTOA. SOHCAHTOA. SOH means sine opposite hypotenuse. CAH. Cosine adjacent hypotenuse. TOA tangent opposite adjacent.
This how you do. This is all we need to know. That's it.
Yeah. And then how to. All right. So what's the word we need to know?
SOHCAHTOA.
We're going to spell it out on the top. You're going to write it like 17 times until you have it memorized. SOHCAHTOA. So the first one is the sine of A. Okay. So we said sine is what two sides? Opposite hypotenuse. So what is opposite the A? 3. What is the hypotenuse of the triangle?
What is that? 5. Oh, it's
5. Okay. Go to cosine of A.
Adjacent.
Adjacent. So what's adjacent to A? 4. And hypotenuse?
5.
Told you could handle it. And the last one for A, tangent of A. Opposite over opposite over adjacent, 3 over 4.
Wait, but
These are the only things you need to know how to do, correct?
Well, then you gotta learn how to apply them. But yeah, these are the only trig functions that you're doing, those 3.
Adjacent was
Sine, cosine,
Adjacent
the
to
hypotenuse?
A,
and I couldn't use
adjacent and hypotenuse can't be. Hypotenuse is hypotenuse. So every one of those angles has 2 sides adjacent to it. But for the acute angles, which are the only ones you're going to find this of, so I can't ask you to tell me the tangent of C. Because it's a right angle, and the tangent opposite and adjacent would be the same things. Opposite would be opposite, and there's 2 adjacent, no distinction. So you're only going to find the trig functions of the acute angles. You can't find them of the right angle.
Or obtuse. That are obtuse.
Well, it's a right triangle, so it has to be a right triangle, so it's always going to be acute, okay? All right, so now you try B. All right, what is sine of B? 4 over 5. Opposite the B, hypotenuse. Cosine of B? 3 over 5. And tangent of B? 4 over 3. See, you could do it. Questions on that one? So that's just setting it up from the triangle. Now we're going to go to the calculator. So we'll do kind of the same pattern we did with tangent. Now we're using the SIN and the COS buttons. So if I want to find the sine of 30 degrees, am I hitting the sine or am I hitting the second negative 1? Or the sine negative 1? Sine. So if I'm looking for the sine, I hit the regular buttons. If I'm looking for the angles, I use the negative 1.
So 0.5.
Yep, so sine of 30 degrees should be 0.5. Yep, a half, that's the same thing. And then cosine of 42, 0.7431. And now I'm switching, so I want to find the angle. So second sine, 0.1045. 5.99836, so 9984. And again, it'll be specific as to what to round to. Typically, the angle is the nearest tenth, so that would have been 6 degrees.
This button, which one's the tangent button?
The one that says T-A-N. Second cosine, 0.9659, which is 15.0057, which would round to 15 degrees. So this would be approximately 6 degrees, and this would be approximately 15 degrees. But I'm pretty sure the homework says what to round to, and on the test I will explicitly state what to round to. Okay, so now we're blending those 2 things together. The calculator, we did with the calculator, now we're solving these triangles using both. It's okay, you can do it. So herein lies the challenge. You have to look at, okay, if I want to solve for x, which trig function do I use? Do I use sine, do I use cosine, or do I use tangent? So you want to pair the x with the side that you're given, right? Because I can't have 2 variables. So if I look at the 28 that I'm given, and I have x and I have 1,000. In relationship to that 28, where's the x? Opposite. Where's the 1,000?
Opposite one.
Hypotenuse. So which trig function is opposite in hypotenuse? Sine. So I'm going to do the sine of 28 degrees equals x over 1,000. Yep. So you're going to get given at least an angle, let's say. So I have that angle, and then I have to pick one variable. I can't do 2 variables at once. So I picked the x. Yeah, well, I just picked the x because I wanted to solve for x. I could solve for y. But you have to have one variable and one side you know. So the side I knew was 1,000. So then leads to which trig function. So x is opposite the 28. 1,000 is hypotenuse. Opposite hypotenuse is sine.
Then what does a 28 have to do with that?
Yeah.
It's the sine of that angle that equals x over 1,000.
But what do you do with this?
So how would I solve this for x?
You multiply.
Multiply by 1,000 on both sides.
How do you multiply the word? What?
Your calculator, you're going to do 1,000 times the sine of 28. And that magical calculator that you'll get, yeah.
What's that?
469 point, we're going to round it to 1 to the nearest tenth, or the nearest integer, it says. Yep. Uh-oh, wait. I know, but.
Oh, I see. There's the 3 of them. Okay.
So now I know the side length here is 470, and that's big, but if you look at the 1,000, it should make sense, it should be big, right?
Yeah.
So now I want to solve for y. Give me 2 ways to solve for y.
Use the 90.
I can use the, okay, so there's actually more than 2 ways. I can use the tangent of 28 would equal 470 over 1,000, over y, that's one way. The only catch there is if the 470 is wrong now, that's wrong too. Okay? What's a second way to do it? What happens when you have 2 sides of a right triangle? I could do the Pythagorean theorem, right? Same catch though. If 470 is wrong now, that's wrong too. So now let's say I wanted to start with y. I'm still going to use 28, but this time I'm using y and 1,000. So in respect to the 28, where's the y? Adjacent. And 1,000 is? Hypotenuse. Which trig function is adjacent hypotenuse? Cosine. Adjacent, which is y, over hypotenuse, which is 1,000. And then I multiply both sides times 1,000. 882.94, which is going to be 883. So for an example like this, you're actually given the side length, but none of the acute angles. So this is the one where you'll be trying to find the acute angle. And so when I'm trying to find the angle, these are where you're going to use your -1. So what you want to do is look at the triangle that you've got. So in respect to the angle I'm looking for, which is x, 18 would be opposite, 30 would be the hypotenuse, and opposite and hypotenuse is sine. So I'm going to say that the sine of angle x equals opposite, which is 18, over the hypotenuse, which is 30. And when you're given the actual ratio and you're looking for the angle, you're going to use the -1 feature. So sine -1 of 18 over 30 would get typed into your calculator just like that. So sine -1, 18 divided by 30. And I end up that x is 36 point, and it says nearest degree. So this is 36.8 degrees, which ends up being 37 degrees. Okay, example 5 says to find the measure of the 3 angles and round to the nearest tenth. So the difference with this one is this is not a right triangle. What you should notice about it, it is isosceles. So for something like this, you'll actually need to draw the altitude down, making this into 2 right triangles. If it's isosceles, that altitude cuts this into 2 congruent parts. So now I know the 2 side lengths of the smaller triangles would each be 2. The hypotenuse of each of the smaller triangles would be 5. So let's start by finding angle C. So if I look at just the triangle that's given, here, the smaller one, I've got 2 side lengths, the one adjacent to C and the hypotenuse of that triangle. Adjacent and hypotenuse is cosine. So I'm going to say that cosine of C equals adjacent, which is 2, and hypotenuse, which is 5. So again, looking for the angle, I'm going to do cosine -1 of 2 over 5. Second cosine, 2 divided by 5 gives me that this angle, angle C, is 66, and it says nearest tenth, so 0.4 degrees. So that's 66.4. I also want angle B, but this is an isosceles triangle, so this would also be 66.4 degrees. And if I look at the big triangle, this top angle is the only one I'm missing. If I add up the 66.4 and the 66.4, I get 132.8. Subtract that from 180. and I end up with 47.2 degrees. So that would be angle A. All right, so quick refresher. I need to know SOHCAHTOA, SOHCAHTOA. And then from my triangle, whatever variable I'm looking for, if I'm looking for the side lengths, I'm using my regular features, sine, cosine, tangent in the triangle, on the calculator. And if I'm looking, if I'm looking for side, and if I'm looking for an angle, then I'm going to use the negative ones. So sine -1, cosine -1, and tangent -1. Either way, you're setting up a ratio. So if this side was x, this is y, this is z. If I was saying sine of angle A, it would be x over y. And I would know two of those three things, either the angle and a side, or the two sides and I'm finding the angle. So you always want to set up the ratio. I could say that the cosine of angle B is adjacent over hypotenuse, which would be x over y. I could be setting up the tangent of angle A, which would be opposite over adjacent, x over z. And again, I would know two of those three pieces of information and solve for the last one. Okay, so hopefully that gets you started on the assignment. And we'll review some more next week.